So last time we saw that this is a statistically significant, and we looked at kind of how we're going to set up our hypothesis testing. That basically there are differences between the mean for each of our basically subvariables. So for this instant, fertilizer 1, 2, and 3. One way that you could kind of start to see a little bit if that's true or not, that all these are a little bit, statistically significant or distinct, we can start to play around with this data set. So for example, let's go through our crop data. So let's go ahead and we're going to go and let's take our, for example, let's take our crop data. And I want to let's do library our statics because I want my statics. Here we go. I want my R statics because I want our df select. So crop dat, and I'm going to pipe it through df select, and I want to select fertilizer. Let's see, hopefully I spelled it correctly. Excellent. And then I'm going to do F1, and then I want to filter, basically, I'm going to pipe again. I want to filter when fertilizer equals 1. And I'm going to do the same thing for 1, 2, and 3. Boom. We're just doing, again, the purpose of this exercise is just to kind of show how awesome ANOVA is. Because we were able to determine the differences between those 3 different parameters in very, very quick lines of code and basically analyzing that ANOVA table that kind of pops out immediately. And I just messed up because let me reevaluate all of these. Good. So for example, let's look at t.test, and we'll take our F3. Let's see. Actually, excuse me. Let's look at how does our F1 look? We'll probably need to bring out, let's see. Hold on a second. So I want to df select, I want fertilizer, but I also want to include in here, I wonder if we can do an and. Maybe we can do this. Fertilizer and maybe. Let's see, fertilizer and yield, maybe. Let's see, I don't want add as numeric. Don't want equals. Let's see, I could use fertilizer plus yield. So let's do df select. df underscore select. Because I want to select multiples. Here we go. So let's do let's say vars equals C, and I want fertilizer and I want yield. So let's look at F1 now. Good. This is nice. Fantastic. So now I'm going to copy this, and I'm going to get to this eventually. Don't worry. We can just copy this in here. We can paste it in for this. We can paste it in for this. And now we're rolling. Good. So I want to just look at, so for example, our F1, and I want to grab, let's say, the second column, because I want to see for this data set, is there differences in the yield? So I'm going to do F1, bracket 2, and let's just say we're working with conf level equals 0.95. I'm going to do our alternative equals two-sided. What I'm doing here, and then let's just set our mu equals to 0, because it doesn't matter. I'm just trying to look at our confidence interval, our 95% confidence interval for this data set here. Because what I want to see is, well, is there a difference, right? Just kind of qualitatively. We could also look at this graphically as well. And that may be a better method as well. And we'll probably look at that as well. But you want to kind of see, and graphically you can actually see it quite easily. And we'll do that after this. But I just want to see first, is there, like, are these confidence intervals for 95%, are they different? So we're going to run through all of these now sequentially. And let's kind of take a peek. So for example, that was for 175. I'm looking if they fall outside of the bounds. So for 1 and 2, 1 and 2, there seems to be a considerable amount of overlap, for sure. But if we look at 3, 3 looks to be quite different. I think we fall outside the bounds of almost all of them. It's pretty close, but we're pretty out of the bounds. We could also just do a ggplot as well. So I can do, for example, we can do crop dat, and we can grab this, but you can already start to see there is a difference. Like, they're not all overlapping. But let's look at that graphically. So now I'm going to pipe it, and I'm going to do ggplot, and I'm going to select my AES. On my x-axis, I'm going to equal my fertilizer. And then on my y-axis, I'm going to have my yield. And then I'm going to plus geom, excuse me, box plot. And I'm hoping that it's going to notch equals true. And then I'm going to say group equals fertilizer. Hopefully, let's see what happens here. Yeah. Let's just try this first. Let's see what we got. Good. So we can look at the notches, and we can see at the very least there's an overlap here, but it looks different from here. So I don't think there's an overlap between 1 and 3. So again, we're seeing visually, again, you see how much work we had to, like, kind of devolve these and look and then kind of get a sense of, okay, is there some statistical significance or difference or not? Whereas if we just bundle all these together and we do our ANOVA analysis, you saw it was 1, 2, 3, and we got it. Same kind of value, that there is some difference. There's some statistically significant difference here. So ANOVA is an amazing kind of tool and resource for us to utilize and to have. Yeah. So let's go next time, and we are going to start to dive in a little bit deeper into this one-way ANOVA and see, can we prove kind of what we see here, that 1 and 2 don't look different, but 1 and 3 do look statistically significant. And then more importantly, are these large effects? Are these small effects? What else is going on here? And then, again, at the end of the day, one of the things that we kind of don't want to lose focus on is, if I were to say I want to use this to determine what type or what set of experimental conditions will yield the largest outcome, like, let's figure that one out too. So let's answer all those questions together. All right. We will see you all in the next video. Thanks.